So today we'll be talking about tracing clues using knowledge graphs to help endangered wildlife. It's just a little bit about me. So I'm a machine learning engineer at Axon. I'm also a master's student at NCS at Northeastern University in the satellite Seattle office for it. So today we're going to be chatting through some of the context around this project, knowledge graphs in a nutshell, a case study involving orcas, how Neo4j really enabled all of this, how you can become a wildlife detective, and then some time to just chat and answer any of your questions you may have. So first, let's understand the context. Why wildlife conservation? Well, according to the WWF in their living report in 2022, biodiversity is down by 69% since 1970, as you can see from this graph that's on the left. That is a massive reduction that we really haven't seen before. Wildlife conservation is thus a critical aspect to our life on this planet and to preserving the remaining diversity that we have and hopefully re-expanding it. But there's a lot of existing challenges, from data collection to financial and resources, to things being understudied, to animals just being kind of difficult to study given, they're a little bit more hesitant and don't exactly come to chat with us very often. There's a massive data deficit as such. It's just not feasible to tag every single animal on the planet, nor do I think they would appreciate it. It can be hard to get data in far reaches of the world, or even in your backyard. Yet we really do need some data-driven solutions. Without them, we're just guessing. We can't know exactly what it is to change in our world to help them. And now's the time before we lose any more. So let's chat a little bit about knowledge graphs. Now, given that you're at Nodes, I'm sure you're a little bit familiar with the knowledge graph, but just in case, it's a collection of different types of data integrated together in terms of relationships. Primarily, you see this in search engine optimization, in analysis around recommendation systems, and honestly, they're used all over the board. How are they different when it comes to wildlife, though? I would argue that the stakes are a bit higher than in a lot of the common use cases. Instead of whether or not you have the best recommendation right in front of you, we're talking about whether a policy changes in time for a species not to die out. And that's a pretty heavy weight sometimes. There's also a very large social collaboration that goes between nonprofits, research labs, government bodies, and the local communities that all need to work in harmony. And the knowledge graph really needs to take that into account, both for who's using it, how their data is being collected, and how those can work together seamlessly. And lastly is the temporal complexity of it. And although modern day life, we do have temporal changes such as seasonal or holidays or shopping, things like that. In the wildlife world, you've got seasons, mating time periods, migrations, and things of that sort that are really going to change your data very significantly from one time period to another. So in terms of wildlife conservation, there's a lot of work being done by both citizen scientists, but primarily by governments and non-government organizations. I would argue primarily research labs. And they are doing a wonderful job integrating, getting a bunch of data, usually in a very narrow set of information. A knowledge graph allows us to integrate these data sources between many research labs and many areas to get a fuller image along with contextual information. This could enable things like real-time monitoring as it's built up, as well as predictive analysis for a more complex ecosystem, and to get a better idea of what something's happening when over a variety of factors instead of just one or two. So kind of what we touched on there, some of the benefits for this is that flexible data integration. It doesn't need to be a certain type of data. It could be unstructured, it can be structured, it can be weather, It can be GIS. These can all work together in unison. And these can allow us to do special types of analysis that might be more difficult to do in a traditional sense, such as clustering analysis or things like that over a complex set of data. It also allows multiple data sets, but it can have some limitations. The data quality can be hard to get. The accessibility of the data can be even more challenging sometimes. And it really depends on what type of data you put in, what you have available, and how you can go about it. So now that we've gotten to see how knowledge graphs might help us in knowledge conservation, I want to dive into a case study involving the Pacific Northwest orcas. So why orcas? I hail from Seattle, and here in the Pacific Northwest, right on the Puget Sound, we have these lovely southern resident orcas made up of 3 pods, and these are our apex predators in the area. They stay here year-round. They've been a cultural icon for hundreds of years with the indigenous people, and they give us clues to the ecological health of the area. It has also been recently argued that these should be classified in the non-human person category, as they have families, cultures, and language. So let's learn a little bit more about them. So this unique and endangered population is only found in the Puget Sound. The Puget Sound is thus a critical habitat. It has essential feeding grounds and is a safe environment for raising their young. Unlike other orcas, such as our transient, who are mammal eaters, these southern resident orcas only eat fish. And the declining salmon population, which is their primary food source, has been thought to be one of the major problems with why they're really not bouncing back. But there's also signs pointing towards noise pollution, as the Port of Tacoma is one of the major hubs in the United States, as well as contaminants, both from shipping and from runoff of places like Seattle, Washington, Tacoma, Washington, and Vancouver, British Columbia. So how do you find out what data sources one can use? I've decided to look through a variety, both from publicly available data, such as what's available from both the US and the British governments, as well as private research labs. Now, these private research labs, you do have to get permission to use their data. And so that can be kind of hit or miss depending on what stage they are in their research and whether or not they've seen your work before, or whether this is something they feel at this point that it's worth investing their time and data into. You can also look for things like citizen scientists. In our area, I was really fortunate to come across this wonderful nonprofit organization called the Orca Network, who has been collecting data since the early 2000s by either text, phone, or email, and posting it on their website. And they graciously allowed me to scrape their website and use all of their data. And then you can also add in things like environmental information. Ship tracking is now available through a variety of different sources of open source data that is available to all, and historical data that you can ask for permission to use. You can also use weather stations to bring in that type of information, and fishing logs, things like that. Then comes the hardest part, at least I think, the data processing. For things like smaller novel data sets, such as what you might get from some of the research labs, you really need to do it manually. There's not enough of the data set to really make sense to try to automate it, but it is time consuming to do this kind of manual integration. But then there's other data that's extremely large. And this is where it can really be helpful to use things like natural language processing or LLMs to be able to turn that unstructured data or structured data into ingest it into your graph database and do entity extraction on it. And this is really important to do for large data sets, as it goes from something that could take years upon years to just less than 30 minutes. Now, LLMs are a wonderful way to go, And I'm not going to touch on it too much here because we've already had a couple great talks at Nodes, and I think there's one more coming up today to how to bring in with an LLM. But they are a wonderful way to handle great large chunks of data with a few examples to help it kind of understand. But you do need to be careful of hallucinations as you do it. So some of the challenges I came across was data inaccessibility. Like I kind of touched on earlier, some research labs are not at the point where they're willing to work with you with their data. This can lock down things that would be extremely helpful. Yet I have found that for every one where there might not be that chance, there's other ways to have similar types of data from other research labs or looking into social media or things like that. So I'd recommend not to be discouraged. And then and the big challenges around data volume. So from the Orca network, between 2000 and 2018 alone, the time it would have taken me to manually process the data was going to be about 32 years from my back to napkin envelope. And a quick check with paying a lot of money on Mechanical Turk, it would only bring it down to 3 to 4 years. This is a pretty clear use case when it's really good to use NLP. And then lastly, some of the data is going to have low quality. So things are going to be missing. Things might be a little bit fragmented. Or in like the case of the Orca network, it could be completely unstructured and it might be difficult to work with. So first, let's go into some examples. Sometimes you get some pretty good ones like this one you see it at the very top. At time 1914, David Bennett said, "They're out and trending north." That's really helpful. It doesn't exactly say what type of whales, but we can assume and hope that, given the Orca network, that he's talking about that. 1815 shows one that's even more specific. I just saw 2 grays classing close to Mariner's Cove. It's wonderful. It gives location and the species, and so we know what we're working with. And then the last one, these always make me smile. There was some information, and then they finished up by letting us know how they were invited for a slice of pizza before they made the trip home, and how wonderful of a time they had. And I am extremely happy for that human who got to have that incredible experience. And it makes it a little challenging as you parse through the data. So now we can see that real world example. Let's dive into a little bit more how Neo4j is the magic that makes this all work. So by creating the knowledge graph in Neo4j, we're enabling being able to do this type of knowledge graph in a way that's embedded within the database and not working against it like a traditional using a relational database and then building the knowledge graph more in the code itself. By using a graph database, it really allows that really speedy lookup times. And I also think it makes it a little easier to ingest as you're already thinking in terms of that knowledge graph and it's already in place. So as we create the knowledge graph in Neo4j, we're going to be taking that data and then we'll want to do an entity extraction. We can use some entity extraction algorithms that are already available, such as the ones from Amazon or Google that you can already get in Neo4j and in Neo4j Aura. You can also use LLMs. And then from there, I recommend extracting locations and doing geocoding and reverse geocoding to make sure you have both the name and the coordinates of all the locations that have been seen. Then comes data modeling. And data modeling is well, I shouldn't say then, this is really part of that data ingestion, but it's so specific to the problem you're trying to solve. Here's an example of a portion of the data model for the Orca graph looks like right now. You can see on pink on the left, our primary situation is these reports that are given by organizations and people in light blue that reference dates and events that are in brown that all involve orcas and their pods doing different activities that have been cited by people. This also has location, and these allow us to be able to understand and query information quite easily. So right now I'm still at the data ingestion stage, so I don't have too many hands-on examples for you quite yet, but what that last data model shows us is that we can answer very quickly Questions such as how many babies were born in 1990? Where do they go during the spring when it's raining? What time periods do pods meet up? And when do they need to cross the shipping lane? And these are valuable conservation questions that previously would have been very difficult to answer with the data available, and typically would have had to have a study where someone was actually hands-on going and seeing where they were doing in spring. So now that you've seen all that, what can be done once this is in and you can answer those kind of policies? We can do amazing things such as informing shipping lane policies on orca conservations. It can be difficult to have a real world impact, such as changing a shipping lane to organizations, if there's not a firm proof that this really will do what it's saying. It's a lot of hassle for governments, and they don't tend to like to do it on a maybe. So having a firm show that this shipping lane is causing the noise pollution that can decrease their ability to hunt and impact their young's ability to swim and talk to their mothers. And if you move it by X amount for this period of time, that's a much more reasonable way to be able to convince your argument and help get everybody on board to save these animals. It also allows for a unified research base. This will enable researchers and conservationists to go further. I think it will also make it possible for those research labs that aren't quite so sure if it's worth it to maybe see the value of being able to put their data into this larger effort and seeing how when we combine our research together, we can go so much more further than when it's separate. And it also allows us to have a better connection to the public, to the research. They can see directly how they're writing into things like the Orca Network or writing it on Twitter can have this positive impact on the world around them. So now that we've gotten to talk a little bit about this study, this isn't just about orcas. This is a blueprint for how all of us can go about becoming a wildlife detective. So I'm going to take a second here. I want you to all type in the chat, what animals would you want to investigate? Doesn't matter if it's something as common as a squirrel to something that's not even here anymore with the T-Rex. It could be any animal, or, doesn't even have to be. But if you want to focus on animal conservation, post it in the chat. I can't wait to see who you would like to look at. So the first big thing you're going to want to do is identify those data sources. These are going to be the soul of your knowledge graph. You can look at scientific journals, government databases. There's going to be citizen science projects in a lot of different, for a lot of different types of animals. Social media can be a wonderful place to scrape data from. You can set up your own collection, whether that's from working with a research lab or a larger organization to put trackers on animals, or having a camera trap in your backyard to see how many times the squirrel goes through your backyard. There's also open source data sets that can be found on Google, as well as Kaggle and a bunch of other places. These can be somewhat limited sometimes, but they can be a wonderful starting place. You are going to need to have some tools. I do recommend having a base in data collection, a little bit of data processing knowledge, some Cypher basics, and Python will make your life a lot easier. That being said, everything you see in that third row, you can learn on the job. It'll be okay. For data collection, there's libraries such as Beautiful Sloop and Selenium that allow you to do web scraping. This can be really handy for tools that don't have APIs. Something like GraphQL can help with those APIs in other cases. For data processing, things like pandas can really help, and named entity recognition can really get you a long way. You want to know some of the graph algorithms available to you in Cypher, not just the ingestion and creation, but also some of the things that we have access to, such as clustering and different things like that. And then Python, Pythoneo, things like that are all going to be really helpful. So now you kind of collected the basics, you're going to want to identify the domain and then understand the context. And why this is such a big deal is that how you set up the data model around orcas and the data you want to collect there, such as fishing and weather, It's going to be very different if you're, say, wanting to look at ants. For one, don't think ants fish very much, but I could be wrong. And you're going to want to be thinking more in the lines of, instead of an individual, maybe around how large their territory is. Something that's measurable and easier to identify than potentially trying to track every single ant. And with these kind of contexts in mind, it can be good to, if you're not sure about that context, to reach out to an ecologist in that field of study. In my experience, they're usually pretty happy to talk to you about what they know about that species and what problems it faces. So with those things, you can find those data sources and you can think through how you want a data model. What questions are you curious about answering? And then from there, you can go ahead with the more technical side of things, which is all going to be ingesting data and then adding in any contextual data. And that contextual data is anything that's not precisely relevant, but can really go a long way, such as the weather, the pollution of the area, human traffic, things like that. And finally, all that together will come into one beautiful place where you can start doing insights and analysis and answering things that you wouldn't have been able to before. Now, I went into this not knowing how to do any knowledge graphs at all, and I've learned a lot of things, and I've learned some things that didn't help quite as much. So some practical tips. My top one is tag your data. If you use a name within your data and then you set it to whatever your experiment was, such as Amazon name recognition, it allows you to pull things backwards. If they do something really funny like measure all weight and sizes as if they were dollars. So I recommend that you version your data. It will really help you as you're experimenting and iterating. If you feel really intimidated by doing something, go look. There's probably a library out there that will help you. And don't be afraid of not knowing. Iterate and experiment. It's okay to not know. And this is an area where there's a lot of flexibility and you can learn as you go. Because there's no right way. There's thousands of ways you can data model this. There's millions of different connections you could make of what types of data you put in or what you decide to leave out. There's no right or wrong way to do it. And remember that the joy of Neo4j is its flexibility. You don't have to get things perfect. You can always change it as you go. So as you're getting started, Neo4j, I think, is one of my top places to send you. Between their books, the YouTube videos, and there are many resources such as the conferences and things like that, they have been there to answer the questions I've run into over and over and over again. Tools like Spacey, Beautiful Soup, Pandas all have good documentation and a wonderful online community that's ready to assist. I also recommend playing with open data sets. If you're not feeling comfortable in a certain area quite yet, play around with these smaller, already clean data sets that will really help get your confidence up and understand kind of how to play together. So I'm going to turn my screen off in just a second so I can see your questions. But I just would like to thank all of you for being here. I want to thank the organizers in Neo4j for having me, and the Orca Network, who kindly have allowed me access to all their wonderful data. And lastly, all the wonderful animals who inspire me to do all of this work. All right, now I can actually see your questions. And we have about 5 minutes left. So if there's any questions at all, I'd be happy to chat about it.